Okay, today we're going to do the sine rule. Now this is different to the sine ratio, right? A sine ratio, being opposite divided by hypotenuse, only works in a right angled triangle, whereas the sine rule actually works in any triangle. Doesn't have to be right angled, and that's the advantage of it. It actually is derived or gotten from the ratios, and this is the proof of that. You can have a look at it. You don't need to know it, so I won't spend time going over it right now. But if you're not sure and you really want to know where it comes from, come and see me. Okay? Now, basically, the sine rule is these two down here. It's the same rule, it's just rearranged depending on whether you want to find a side or if you want to find an angle. All right, so if you want to find a side, remember the sides are the lowercase letters and the angles are the uppercase letters. So the sides go on top. If you want to find an angle, the sines of the angles go on top. All right. Now, basically, you only ever use 2 out of the 3 parts of this rule, depending on what information you've got. So let me show you how that works. Now, I've just changed the example slightly because the one that was there wasn't actually a real triangle, didn't work. So I've just changed that for you. All right, so let me just do it on a piece of paper here. Okay, so we've got angle A being 34 degrees. We've got angle B being 50 degrees. And let's make side A 12 centimetres, and we've got to solve the triangle. Okay, actually no, so we'll make B 12 centimetres. So that's the information that I've got. I always write my ABCs in my capitals and my lowercase. You can draw a diagram if you like. It doesn't hurt, but it does take a little bit of extra time, which you don't necessarily have to do. Okay. If you were problem solving, I would say definitely, but these are just very straightforward questions to start with. Okay, I'll just bring that over so you can see a little bit better there. All right, now, as soon as you've got 2 angles, you can find the third because you know that 3 angles add up to 180. So take away 50 and take away 34, and that actually gives you 96 degrees for angle C, okay? Because the word solve, if you're asked to solve a triangle, you need to find all 3 angles and all 3 sides. Now I need to move on to my sides. Now I notice that I've got angle B and side B. That's a great indication that the sine rule is the one that I want to use. Whenever you've got 2 corresponding angles and sides, so of the same letter, we use the sine rule. I'm trying to find side A, so I'm going to put that on top. And I've got B, so I'm going to use those 2 parts of the rule. Okay, so now I put in my information, sine 34. Notice that you can leave out the units when you put it in here, but do make sure that your calculator is in degrees, not radians. Now I've got to get rid of this divide by sine 34, so I'm going to multiply by sine 34 on both sides. And then that's what I'm going to do on my calculator. So 12 divided by sine 50 multiplied by sine 34. And that gives me 8.76 centimetres. You only put the centimetres in at the end. Okay? All right, so now I actually have that one. Now that I have that, it's a bit hard to see, isn't it? Now that I've got that, I could actually use A or B when I go to find C in the next one, but if I've made a mistake there, it'll mess up C. So I am going to use B again. Okay, so I'm going to this time find C, so I'm using that part of the rule. And because I've got that information given to me, I'm using that part of the rule. So I'm just doing exactly the same thing again. C on sine C, don't need the degrees, equals B on sine B. And I multiply each side by sine of 96. Do that on my calculator. Oops, actually I forgot my bracket there, sorry. There we go. And that gives me 15.58. Now you'll also notice that if I go back up here and write those on here, so A is 8.76 and C is 15.58, a little check for the reasonableness of your results is your shortest side should correspond with the shortest angle. So side A is the shortest side, so that means that angle A should be the smallest angle. And it's the same here with the largest. Angle C is the largest angle, so side C should be the longest side, which it is. Okay? All right, now very quickly I'll do where you actually have to find the angle using the sine rule. Okay? And this is actually put into a real life example. Okay, so from point P, a ship S is sighted 12.4 kilometres away on a bearing of 137 degrees. All right, so I'm going to do my bearing of 137 degrees. Oops, I might just do it on a spare piece of paper. There's not a lot of room there. Okay, so let's do a diagram. We've got a bearing of 137 degrees, I would assume from true north because it's not a 90-degree angle. Okay, so I'm coming around 90 and then I would have to go another 47. And I try to make these as accurate as I can. So that one is 47 degrees in there. Okay, and that must be point P. And this is the ship S, and it is 12.4 kilometres away. Point Q is due south of P and is at a distance of 31.2 kilometres from the ship. Okay, so it must be down here. 31.2. Oops, sorry, that's not right. It is south and it is a distance of point Q, 31.2 kilometres. Calculate the bearing of the ship from Q. So we want to know this angle in here. Okay? All right, so let's have a look. I've got PQS, so I'm going to write that down. And this is the one that I want to find. I'll always put a little star next to it. Okay. Now I know that this one here has to add to 90, which means that gives me 50, 43. That must be 43 degrees. So I'm going to call that angle P, 43 degrees. Okay. And I've actually got side P, 31.2. And I've actually got side Q, which is 12.4. Okay, so I can see already that I'm going to be using P, and because I need to find the angle Q, I need to use Q. So I just change my rule. Now, because I'm finding an angle, I'm going to put the signs on the top. Okay, so I'm going to go sine P over little p equals sine Q over little q. I'm going to put my information in. Sine 43 over 31.2 equals sine Q over 12.4. Now I'm going to multiply by 12.4. doesn't matter if that's there or not. Now, just be careful because this is not going to give me the answer. It's going to give me the sine of Q. Okay, so 12.4 multiplied by sine of 43 divided by 31.2 gives me 0.28. Now, I just leave that on my calculator, and then I need to do an inverse sine to find angle Q. So I go inverse sine of the answer, and most calculators have that capacity, and it gives me 16.32 degrees. And that would be my bearing of S from Q, because this is direct south. That is 16.32 degrees T. Okay.